Okay, in this video here, we're going to talk about power regression. We've done linear regression, we've done quadratic regression, we've done cubic regression, and so on. And if I look at my calculator, we've done so many of these. We have linear regression, quad, cubic, quartic regression, so on. There is even, this is natural logarithm regression, so logarithm regression, exponential regression, and then A is power regression. There is a logistic model, and there's also a sinusoidal regression. So there's lots of different ones. But we're going to look at the power regression, and I've just thrown some random values into L1 and L2 just to go through the process. And so I would see here I have an A value of 2.06. The B value is the exponent. And so power regression ends up being y is equal to some value A times x to an exponent b. And so if you look at power regression and you consider direct and inverse variation, you can see that they're really all connected to each other, because if the b value is positive, then I know that it's direct variation. If it is negative, then it's going to be inverse variation. It also deals with the sum of squares to make this regression line, and we can see the r squared value, the coefficient of determination, is quite high for the values that I chose. So that's power regression, and our calculator will do it. It's a little bit more finicky with the types of values. It's not 100% good, because sometimes it doesn't like the numbers you put in, but it's not bad. All right, so let's do another example now. So let's consider a bowl in the photograph. So here's our bowl in our photograph. An engineer wishes to program a wood lathe to cut the bowl and needs to program the equation of the outside of the bowl. So we want an equation that goes around the outside of the bowl. Okay, a model for the bowl is considered. So the bowl is equal to ax to 2.3. One of the points that outlines the bowl is 4, 2.9. Determine the value of a. Well, it's quite straightforward. This here, 4 is my x, so 2.9 is my b, is equal to a. X is 4 to the power of 2.8. They've already given the exponent, and so a is going to just be 2.9 divided by 4 to the power of 2.8. Now if I go to my calculator, it's just going to be 2.9, divide that by 4 to the power of 2.8, and I get 0.0598 to 3 significant figures. So if I go over to Desmos, let's take a look. Here's my graph, and when I did regression just from Desmos with all these values, I got a really close value. But if I want to try the one that we just typed in, I get y is equal to 0.598 x to the power of 2.8. And I have to put an extra 0 because I mistyped that. There we go. And you can see it fits it quite nicely to the parabola, or to the bowl, and we have a kind of parabolic-ish shape. That is power regression.